Hello, welcome to Math 1324. This is Chapter 4, Section 1, Example 6, 5, somewhere in there. Yeah, whatever number you see on Blackboard. Anyway, for this one, we actually have a question that we want to set up. So it specifically says to set up the initial simplex tableau that could be used to solve the following problem by the simplex method. So we specifically want to just set up the initial simplex tableau. Okay, so it says the Fancy Fashions, an independent local boutique, has $9,000 available each month for advertising. Newspaper ads cost $500 and no more than 40 can run per month. Internet banner ads cost $20 each and no more than 50 can run per month. TV ads cost $1,000 each with a maximum of 15 available each month. Approximately 5,000 people will see each newspaper ad, 3,000 will see each internet banner, and 11,000 will see each TV ad. How much of each type of advertising should be used if the store wants to maximize its ad exposure? Let X1 equal the number of newspaper ads, X2 the number of internet banner ads, and X3 the number of TV ads. Okay, there's a lot to unpack here. So let's begin with our objective. Okay, so we're going to want to maximize what? Maximize the ad exposure. And because we don't have it defined for us, we need to go ahead and say let Z equal the number exposed to ads. Okay, so with this, now that we know the objective, let's try and figure this out. We need to find our constraints. Well, first of all, we already know that x1 must be greater than or equal to 0, x2 must be greater than or equal to 0, and x3 must be greater than or equal to 0. Because these are all ads. There's no such thing as a negative ad. You can't unrun an ad. It doesn't work. Okay, so what do we see for the constraints? In the constraints, what I like to do is I like to label what they are. Okay, so there is a constraint in here for money. So $9,000 available, right? So if we have $9,000 available, that means that money is a constraint. So this first row, I'm going to talk about money. Okay, so looking through here, newspaper ads cost $500. So it means that $500 for every newspaper ad. So 500x1. Internet banner ads cost $20 each. So that's internet banner ads. So it'd be plus 20x2. And TV ads cost $1,000 each. And that'd be what x3 is. So that'd be plus 1,000 x3. And that's everything that we'll run. And that means that all of that must be less than or equal to the total amount of money that we have available for us. So out of that 9,000, 500 for every newspaper, $20 for every internet banner ad, and 1,000 for every TV ad. Good. The next limiting factor in this is that we have a certain amount of time available, time and space. So I'm going to do, say, number of ads that are available. Okay, so notice that in here, newspaper ads cost $500, but no more than 40 can run per month. So if no more than 40 can run per month, that means that less than 40 can be. So that means that x1 must be less than or equal to 40. Okay. Then let's go to the internet banner ads. No more than 50 of those can run per month. That means that for internet banner ads, that has to be less than or equal to 50. Then we also have the constraint for the TV ads. There must be a maximum of 15 per month. So that means that x3 must be less than or equal to 15. So not only do we have the implicit conditions that x1, x2, and x3 must be greater than or equal to 0 for each one of them, there are explicit conditions where they cannot be larger than a certain number. Okay. Now, what's left over? Well, what's left over is actually our objective. 5,000 will see each newspaper ad. 3,000 will see each internet banner. And 11,000 will see each TV ad. So that means that Z is equal to 5,000 x1 plus 3,000 x2 plus 11,000 x3. Good. And looking through here, have I used all of the information? I believe I have. Yep. So there we go. Notice that we have actually 4 different slack variables that we need to account for. So when we're doing this, I probably shouldn't have said that this was the number of ads available. So I'm going to say the number of x1 is newspaper ads. The second one was the number of internet ads. And the last one is the number of TV ads. Okay, good. Now this is important. It's important because each of these are going to give us a different slack variable. So we need to understand what the slack variables represent. So in this question, S1 is going to represent the slack in the money. S2 will represent the slack in the newspaper. S3 will represent the slack in the internet ads. And S4 will represent the slack in the TV ads. Okay, so out of all that, we can go ahead and write down our system of equalities. We'll have 500 x1 plus 20 x2 plus 1,000 x3 plus 0 s1, sorry, plus s1, my apologies, plus 0 s2 plus 0 s3 plus 0 s4. Remember, we have to have 4 slack variables, and also account for our objective. And all of that's going to be equal to, in this case, 9,000. Good. That's for money. For the next one, we just have x1 and then plus s2 is equal to 50. For the next one, we have x2 plus s3 is equal to, sorry, that was 40 at first, wasn't it? This one is equal to 50. And then the x3 plus the s4 is equal to 15. Good. And for the last one, remember that the variables over here need to be moved to the left-hand side. That's going to make that negative 5,000 x1 minus 3,000 x2 minus 11,000 x3 plus z all equals 0. Now notice I didn't account for all of the zeros in here. It's a little bit weird to do so, so I kind of left it off. But if you want to see it, here's what it would look like. Plus 0 x2 plus 0 x3 plus 0 S1 plus 0 S3 plus 0 S4 plus 0 Z, and then 0 X1 plus the X2 plus 0 X3 plus 0 S1 plus 0 S2 plus the S3 plus 0 S4 plus 0 Z is equal to 50. And then 0 X1 plus 0 X2 plus X3 plus 0 S1 plus 0 S2 plus 0 S3 plus S4 plus 0 Z is equal to 15. Then for the last row, we still have to add on plus 0 S1 plus 0 S2 plus 0 S3 plus 0 S4. Whew. Awesome. And I guess technically I could have done zeros there for all those. Alrighty, now that we have that, we just convert this into a matrix, and that will be our initial simplex tableau. Now notice that there are 1, 2, 3, 4, 5 rows, 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. So 5 rows and 9 columns. Means that there will in fact be 45 numbers, and that's what we have here. So it's a 5 by 9 matrix. Okay, so let's go ahead and write down our matrix. I'm going to go ahead and go by columns. It's just easier to write everything down. So we have 500, 1, 0, 0, negative 5,000. Then we have 20, 0, 1, 0, negative 3,000. Then we have 1,000, 0, 0, 1, negative 11,000. Then we have 1, 0, 0, 0, 0. Then of course 0, 1, 0, 0, 0. Then 0, 0, 1, 0, 0, followed by 0, 0, 0, 1, 0, then 0, 0, 0, 0, 1, followed by 9,000, 40, 50, 15, 0. Vertical, horizontal. Awesome. There is your initial simplex tableau. Alrighty. Well, there you go. I believe that is that is the last example for this question. Sorry, this is the last example for this section, which means in the next section we'll actually start solving these questions. Alrighty, well, I'll see you there. Have fun.